overloading methods runs a risk of ambiguity. And ambiguity just refers to a method that we might have that has the same number of parameters. So let's say, for example, let's pop over to our pay calculations method, and let's say we have a method that says calculate gross, and we want to determine like a person's pay based on, if they're in salary, the number of pay periods they have. So I would say something like calculate gross pay per salary. Let's say they have a double salary and a double pay periods. And I'm just going to determine the gross pay per check by passing in a value of like return salary divided by pay periods. Now this clearly is bad code. Pay periods would be an integer anyway, but I just want to show you guys what would happen. So now we have a bunch of things happening up here we don't really care about right now. We're going to talk about it later on. But we have a calculate pay, your hours worked and your current pay rate, that the computer is not going to know where to go to. And what's going to happen when we try to run this pay calculations is very simply the computer it'll be an ambiguous structure and it will fail at compile because we have two different methods that say double and double. Of course, the simple way to fix that is to do this properly and change one of the pay period methods, making that an integer instead of a double. When we do that, we no longer have ambiguity, and the program, I didn't save it, the program will be allowed to compile. And I'll show that to you as well. No problems with compiling, and really no problems with running this program either. So it's important that we avoid ambiguity by changing the parameter list either, and this is based on data type, so we need to have a parameter list that has different data types every time we build a method that's overloaded.